Okay. Welcome everyone. This is the presentation of an intelligent healthcare modular library, mainly powered by Green Prefab and Kreo software, and also with Axis Corp from the US. This presentation is divided in three topics. First of all, an introduction to modular construction. Then the proof of concept of how a digital library and a generative design software can help the healthcare industry. And then some very successful cases from the US done by Axis Construction Corp. Why modular? This is a question that it's been in the market for several years, but I think that construction, will move in the following years to some kind of manufacturer or industry 4.0. Why? Because, it's the only way to certify performances, to be more faster, and to be able for the construction industry to scale in the level that, in this case, healthcare needs. We start after the COVID-19 outbreak. We start as some modular industry receiving a lot of requests. It was like a very difficult situation because everyone were willing to enlarge their healthcare capacity, but there were no standards, there were no requests, there were no even tenders and even budget. So we start to think how to aggregate some kind of network between all the manufacturer capacity and resources all over the world, plus the engineering companies, and how to be able to aggregate this kind of resources and capabilities in order to supply the industry. And it was really very difficult. So we got to the point that, it was a very important thing in order to tell the people that and the companies that were requesting for modular facilities and modular infrastructure, how to help them to define what they need, so we start to aggregate the capacity and also define the different solutions that modular industry can supply. At the very end, we got to the point that it was very important to deliver a quick response for this kind of feasibility studies. We need to match the offsite standards with the healthcare building codes. It was very important to industrialize the design and trying to match, the possibilities of modular construction with the healthcare needs. And it was very important to adapt the manufacturing capacity through some kind of digital platform or solution that could help, make the things so easy. So we start to think about how to design some kind of building blocks in order to give the healthcare industry some kind of presetted designs in order to be able to build this kind of projects with what in the modular industry we have as some kind of standard design limits, that are related to the possibility of transporting, the possibility of manufacturing, the possibility of assembly. So we, after studying several projects, we got to some kind of general pattern of healthcare design, and we built a library for all the operative parts of any kind of healthcare design. You know, we took some kind of the standards of Christopher Shaw from Riva Architects about different healthcare buildings, and we got to design different modular and several modular, 160 modular building blocks in order to be able to solve all the possibilities of healthcare design with a standard modular solution, which after using those blocks, we are able to solve different kind of healthcare buildings, where it is a regional clinic, which is maybe a diagnosis center, diagnosis and treatment center. So we match all the patterns and all the requirements and the limits of modular construction with the healthcare buildings. The main idea is to have in some construction and healthcare standards building blocks which are totally matched with the off-site construction industry, and trying to avoid the every time design, you know, upon scratch of a healthcare solution. Now we're going to present the combination of that digital library with a generative design software in order to have to speed up the design process, to have early feasibility and design studies, and to be able to connect the construction industry through these building blocks, and to be able to have a design process quickly and having you know, very quick outputs of that. This is the solution that Kreo software have developed, and now we are going to move to Mac in order to present the solution of Kreo software.
Thank you, Franca. Okay, so I'm going to explain a bit about what Kreo Modular does, and also I'm going to explain a bit what we achieved together with the Green Prefab, how we automated this building concept. So first of all, I'm going to share my screen, and let's start with a few words about Kreo Modular itself. So Kreo Modular is a software which actually help clients to automate building concepts and basically to accelerate feasibility studies, to generate 3D models quickly, and to get all necessary dashboards. So basically, as you see here, we usually work with different volumetric modules, and we kind of, as you know, every building contains, you know, like every building DNA contains kit of parts and topology. And so basically topology is about spaces which your building has, and kit of parts is about real objects like walls, windows, doors, etc. Right? So in a volumetric modular case, it's pretty good case because actually your kit of parts, they basically map with our building topology, and this is why it's really kind of good and comfortable for us to automate that building concept. So what we did, first of all, we worked together to define the library. I'm going to show a simple scheme of what does library mean. So basically, library means that it has a different set of modules, and we know how these modules can be connected together, not only in horizontal direction, but also in a vertical direction. And we know how these units or groups can be connected further for building parts or for building blocks. And after that, we know how these building blocks can connect together. This is exactly what we call the building DNA. So Green Prefab developed a well thought out modular system. And basically, they explained for us how this modular system works. I just will show you a few kind of tables where it was explained. I don't want to spend a lot of time on these numbers, but I just want to explain that, you see. So basically, this is what library means. As you see, we have a different blocks, different sizes, different description, and we have a different relations between other blocks. So we have a group, we have a kind of a blocks which is included in this group, at what level, how they aggregated, and stuff like that. And so basically, this is how the modular system can be described, right? And we also know that at the end of the day, we need to get basically, for any building hospital, we need to understand like a hospital main features, how many regular rooms, how many intensive care rooms, how many emergency rooms and regular surgery rooms we will get at the end of the day. And this is what we can, this is the main question on which we can get answer with help of Kreo Modular. Okay, let's get started. Let's go in Kreo Modular and let's open our hospital library, which we automated for green prefab. So it's a proof of concept. It's not a kind of a ready product. It's just a proof of concept for this idea. So as you see here, we have our library, which actually contains a lot of different modules. I can say that all of these modules, they're more or less the same size, but they have a different functions, right? So if I will show you this module, you will see how it looks, which spaces it has, how the corridor connected. If it's necessary, the user can actually change these things. We can move doors, windows, we can move walls, but this is not super important. Another part of the software, it's about unions, or what we call it within a hospital concept, groups. So basically here you have the whole group, like a surgery or pharmacy or delivery or whatever, right? Or multiple intensive rooms. And in this group, we basically have a few modules connected together. One module, two modules, three module, and it's explained to our software that how they should connect it together and how these groups after that can be connected together in the kind of layouts. And this is what we have here. We have a bunch of different layouts, and our algorithm can actually generate a lot of possible combinations of modules inside this particular footprint. And when we will kind of present a project, I will explain what I mean. So basically here we have a layout, which is itself pretty independent part of the building, of the hospital. And this particular layout, it has its own topology, and it's said that this layout can be connected by this wall and by this wall, and we have another types of connections in the vertical direction. So we can put only stackable modules on each other. Okay, so this is basically how library looks like. Again, modules, right, groups and layouts, and after that we can create a hospital project relatively quickly. Let's just go and create a new project. We will call it, let's say, demo, and we will press on next step. And here we just need to find the proper site for our hospital, right? For example, I'm not sure. Let's say we want to build something somewhere here. And what I need to do, I basically need to draw my site. So I'll just draw a random site, stuff like that. And after that, we actually have access to all our layouts. We always can edit our site. We always can, you know, just adjust this layout for specific needs. So we can, you know, overlap the site boundaries. So we can be quite flexible. So this is how we can connect all these parts together, and you know, and after that we can make this hospital, move it a bit. So for example, we can choose it. We can create another one. So we basically have a library of different enlarged parts. And we can kind of create another one. And you know, all these things, they can even be connected together automatically. So basically we don't need to do it manually, but I'm just, you know, for the sake of transparency, I just want to show how it can be built manually, and after that I can explain how it can work in a generative mode. But basically, as you see here, this is what we can build. And actually, as you see here, we have a building which contains 3 blocks. If I will go to block number 1, I can build up a 5 stories, and this is exact place where we can kind of adjust our stories, because for each layout we have a different kind of a possible templates. And basically, I can go to the level number 1 and I can adjust just simply another template. I can go to level number 3, I can adjust another template. And this is how I can go from level to level, and I can apply completely different templates. And actually this one is probably appropriate for the footprint, and this one, for example, here we can see different mix, and any updates I do, they all immediately will be shown here. So we have a common room, room 1, CUs, and different amount of total unit mix. As I go further and I save this particular layout, I can see how my units stacked. So here, and I can go to different building block to this one, and I can also build up something here. So I can use different templates. I can see my analytics. When I apply stuff, I will see analytics for the whole building. We can see how many diagnostic units we have, surgery units, 1P rooms, 1 CU rooms, and stuff like that, and total amount. And basically, this is quite easy way to kind of to build a hospital, to generate a 3D model of the hospital. And when I choose everything, basically what I need to do, just press the next step and design. And the 3D model with all necessary dashboards and analytics will be generated in less than 3-4 minutes. Okay, while it's calculating, I'm gonna show you kind of already calculated project. And let's say we have this particular project which contains 2 hospitals. I can basically go to 3D model and we'll see how it looks like. Example here, just bear with me a second. It's need to be updated. So yeah, we have particular site, we have our hospitals, we can check different views. This side, we can jump inside, we can check how it looks from here, or we can even go through the hospital. We can walk up, right? So we can go inside, we can see our lobby, we can see our spaces, we can go closer to here. It's our room, we have a furniture. So basically we can kind of check by ourselves how this room looks like. We can do different cross sections, and it's, you know, it's pretty well detailed, I would say, well detailed conceptual models. And, you know, as you see, they have different modules, module 1, 2, 3, etc. We have different modules from this side. We have this kind of a, let's say, traditional part of our building. So basically the building topology contains traditional part, which is more like it can be reinforced for concrete or steel structures, whatever. And we have these wings, which created fully of modules, and we can stack them together, and we can put them on each other, etc., etc. So this is how the project can look like. 3D model, we can dive deeper into any model, and for each model, we'll have analytics where you can check unit mix or group mix or something like that. While I was showing you how it works, our project, which we created together during the demo, it's already calculated. And we actually can jump into building number 1, and we can open it. So you will make sure how quickly we can really create a model, okay? So basically here we have what we created together. So we created, you know, as you see, we used a different layout for this ground floor, and this is why we have a different situation here. We can go to corridor, and again, we can go inside, we can check everything, etc., etc. Okay, so I just don't want to spend more time. That was kind of a basic explanation of what does building concept automation means, and that was a proof of concept of what we automated for Green Prefab. Okay, so Franca, thank you. Word back to you. I'm gonna stop my sharing screen.
Okay. Thank you, Matt. You know, for sure, you are the brain behind the artificial intelligence. And now we are going to present, you know, some kind of successful cases, because, you know, this kind of approach, you know, having a digital library with a generative design, it means that we need to match it with the real industry. And now we are going to give the space for John to let us, hear some kind of really successful cases about the healthcare industry, mainly done, of course, in New York, where John is based. So, John, are you there?
I am. Thank you. Appreciate you having me and joining you today with this. So as Franco and Mac is already pointed out, this all came about after the start of COVID last year. And one of the things that we quickly found out as a group was that the healthcare industry desperately needed quick solutions to solve pandemic problems, whether it be a pandemic, a natural disaster. And one of the things that we kept hearing from all of the healthcare centers that we deal with is that we just couldn't provide space quickly enough. Briefly about Axis Construction, we're located just outside of New York City. We specialize in healthcare construction, both on a conventional and then also modular level. I've been with the company over 22 years running the modular division and doing nothing but modular for over 35 years. And we've really tried to take healthcare modular to the next level. So when this opportunity was presented to us via Green Prefab and Kreo, we jumped right on board because, again, one of the things that we find with our clients is speed, schedule, particularly in times of need. So this particular project is the Good Samaritan Pediatric ED. It's approximately a 7,000 square foot modular addition that we put onto a hospital, Good Samaritan Hospital in Long Island, specific to pediatric. They're the only level 2 pediatric trauma center on the southern shore of Long Island. And this particular facility sees over 19,000 patients per year. That's how many visits they have. So the area was severely undermet with this need. And they saw the need and wanted to get something done quickly. The hospital itself is located in a very dense urban area. So disruption was a problem for them. Speed to market, obviously. And then they also did not want to interrupt their existing operations. This addition was being attached directly to the existing ER, and then a separate wing was created with this for the pediatric. We broke ground at the beginning of March of 20, and we all know what happened about a week later. The pandemic really took hold and struck. So we had to deal with this right throughout the pandemic. And in spite of that, breaking ground in March, we were able to complete and finish this building and have patients in it by July 1st. And that was with meeting all of the DOH, Department of Health requirements, all of the AHJ requirements, building code requirements, Article 28, if you're familiar with that. So this is a full functional, fully approved, certified healthcare building that we did out of a modular fashion. And again, what we tried to utilize here were, as Mac mentioned earlier, was simple blocks, so to speak. Most of these modules were all in the 12-foot by 40-foot size range. And that's something that's very important, as Franco had also earlier mentioned, for shipping transportation. So next slide, Franco. I don't know if you can play this video. This is a quick video that really sums up. Yeah, I'm not sure if you're hearing the sound.
The one from ground zero that was part of this entire planning process and helped make the decision that offsite modular was the way you're going to go.
As with many other hospitals, particularly in highly populated areas, space and land is always a problem. John Bongiorno. came and introduced me to this notion of a modular construction, whereby we could reduce the laydown area for the project and speed up the construction, thereby reducing the amount of disruption. We started, I think we broke ground in around March or February or something. And here it is in June, and the building's up and we're ready to see patients next week. We were able to construct the foundation and do all of the site work at the same time that you guys were building the building. Even more impressive than how fast we were able to finish the project by doing this kind of simultaneous construction was the fact that we got hit with a pandemic. Through the entire process, we didn't miss a beat.
The COVID pandemic actually sped up this process.
Right.
And really pushed us as we saw a need to have dedicated space, private rooms for our patients.
Right.
And the fact that this was modular construction obviously was great, not only for us on campus here, but for the entire community, because there was a lot less disruption.
This is really an eye opener how this can go. I mean, this thing came complete. You had the walls primed and the oxygen outlets in and the doors hung and everything was taped shut. And it was really quite incredible.
Even the pneumatic tubes were in for the pharmacy feeds,
All you had to do was connect it.
Everyone that walks into it and walks through is pretty amazed. If we didn't tell people it was modular, there's no way anybody would be able to tell.
So thank you, Franco, for playing that. That video there and those interviews were totally unscripted. That was basically a reporter that came to the site for their grand opening and interviewed those folks from the hospital. And it just really captured the essence of what volumetric modular building is all about. The schedule, speeding up schedules, cost certainty, lack of disruption, not only to the campus itself of your site, but then also the neighborhood, the surrounding neighborhood. So it really captured everything that we're about and what this industry can do. And again, as I stated earlier, what the pandemic showed us was that we were not able to quickly deliver product to the facilities. And that's where Kreo's library and design work with green prefab really is going to speed this process up, whether it be just in a normal situation or if we ever get hit with another pandemic or natural disaster. This next slide that you see here, the Gotham Medical Health Center, this is a 2-story, little over 20,000 square foot building that we did in New York City on Staten Island for New York City Health and Hospitals. The area was severely underserved again. The challenges that they presented to us was, again, neighborhood, healthcare delivery to the community, and there was a requirement to meet LEED Silver. So again, what we did, we partnered with their manufacturing partner, and we were able to come up with a solution, and we were able to deliver this building and get them into it 9 months earlier than what their conventional construction called for. Again, this is a full service healthcare facility for Staten Island, many exam rooms, dental rooms, x-ray rooms, all the services that the community needs. The site was specifically picked along a main corridor where public transportation was accessible. We did achieve the LEED rating that was desired of silver. And again, this was 58 modules that we were able to set in New York City in just 6 days. And then within approximately 2.5 months, we were able to finish the complete building, get the full occupancy permits, both from New York City as well as the DOH and other agencies having jurisdiction. So again, it was a successful project and just another example of what you can do with full volumetric modular. I don't know if you want to click to the next slide, Franco. And then these are just some pictures of some other buildings that we've done, whether it be a radiation oncology center in the bottom left, eye exam centers, clinics down in the bottom right. We can do wide open spaces, waiting rooms, and then another 2-story building, about a 30,000 square foot building that we did as a health center for adults and children with learning disorders. It's a very unique building that provides services to folks that have some extra special needs, but deserve the same type of care and respect that we all get. I mean, you can see the detail that we can provide. So again, very important to understand that full volumetric modular can provide you just about any look you want. And it's all about building within those cubes, which Max and his group have really started laying out a great library with, and we're very excited about it. So Franco, I appreciate you having me join you guys and being a part of this. I'll turn it back over to you, and enjoy the rest of the conference.
Yes, well, and thank you, John. It was incredible, all your experience and all the things you've done. Just to end this kind of presentation and going back, what is future? We are totally convinced that the construction industry that haven't been disrupted, as other industry in the last years, is moving towards this direction. It's the only way in order to, increase the sustainability, the productivity, and to deliver, what the world needs, that needs more buildings in a faster and is in a smart way. So we are totally convinced that this is the only solution, because it's the only way to match, some kind of industry standards with the science needs. So, and of course, using the artificial brain. I think that this is the solution. We are totally willing to receive any kind of comment, any kind of request for information. I think that, developing this kind of integrated tool will help the healthcare industry in a great way. And yes, we thank you. If you are able to see the presentation, we totally appreciate your time, the time you spent here. And you will have all our contacts here, and all our willingness in order to move forward to develop furtherly this kind of solution, which we think that is the future. Thank you so much.
Thank you, everyone.
Thank you, everyone.
Thank you.